Hi, how you doing? So in this video I'm going to show you how to find the standard deviation when you've got a frequency table. Okay, so something like this. Okay, again, not too complicated. So you've got the x values, but then the frequency values, which obviously means you've got 5 2s, 12 3s, 13 4s, 10 5s. This is more realistic in terms of a slightly larger data set. It's not listed, it's put into a frequency table. Okay. In terms of the formula, let's just have a look at that, because hopefully you've watched my first video on how to find the standard deviation and you're comfortable with that formula there, okay? Well, the formula just changes slightly, okay? Can you see? We just inserted an F there instead, an F there instead, okay? Just because we've got a frequency value, all right? Let me just take you back to what you would have done to find the mean in GCSE maths, okay? Assume you can remember that far back. So using X bar again to represent the mean, what you would do, of course, is you would multiply these together. Do you remember doing that? Okay, so you do 2 times 5, and then you add 3 times 12, then you'd add 4 times 13, then you'd add 5 times 10. Okay, all of those. So the notation for that is you do sigma fx. Okay, and then you divide by the total number of values. Not use n this time because you've got frequency. I'm going to denote that as sigma f. Okay, so sum of the total number of values is by adding the frequency together. So if we do that, it's 5, it's 17, 30, it's 40. Okay, so if you recall, that's how you were asked to. That's how you work out the mean. Okay, at GCSE level. All right. And in terms of what it looks like in the formula, I've replaced that bit in some formula that you might find on on the internet. Okay, I'll just replace that by writing x bar squared. Okay, so that bit to find the mean is just there. Okay, I'm going to work out what that is now, and then I'm going to bob it off so I can find some more room for my working. So we're going to have 10 plus 36 plus 52 plus 50. Okay, all divided by 40, and that gives me 37 over 10. 3.7 if you want. So let's just write 3.7, okay, because I know some of you prefer decimal, I don't. Okay, but we write 3.7. It is statistics, sometimes it's more appropriate to write it as a decimal. Okay, it's 3.7. Okay, so that's that, okay. I'm going to write it up here so we don't forget, because obviously we've got to use that for the standard deviation, which is coming up next. All right. Now, the standard deviation, we do exactly the same sort of thing as what we do with finding the mean. That is, we've got to take into account the frequencies. Okay. Now, if you remember, well, this is getting a bit worn now, isn't it? Okay. But if you remember on this formula here, okay, we squared the x values. We're going to do the same again. So we're going to do 2 squared, 3 squared, 4 squared, 5 squared. Only we've got to multiply each of those by the frequencies because we've got 5 of those. So 5 lots of 2 squared. Okay. So I'm going to write that in here. 5 multiplied by 2 squared, and then added to 12 lots of 3 squared, because we've got 3 squared, but 12 of them, 3 squared times 12, added to 13 multiplied by 4 squared, added to 10 multiplied by 5 squared, and I can just about fit all that on. Okay, and then we're going to divide that by the total frequency, so 5 plus 12 plus 13 plus 10, which was 40, wasn't it? And then we're going to subtract the mean squared. So subtract, just squeeze it on there, 3.7 squared. Just put it this. I tried to be clever there by inserting brackets, but it didn't quite work out. Do you mind if I just put 3.7 squared like that, just so it fits on, and then square root everything? Okay, and then that's it. All right. So I'm just show you that formula again. So using this one, the preferred one, okay, because it's quicker and easier. That's all we've done. Okay, so we've got sigma fx squared, so that's this line here, so 5 times 2 squared, 12 times 3 squared, and so on, all divided by sigma f, the total frequency, which is 40, subtract the mean squared, so subtract 3.7 squared, okay, that's, we're going to do that there now, for the time being, and then let's work out what that is. So 5 times 2 squared, okay, plus 12 times by 9, plus 13 multiplied by 16, plus 10 multiplied by 25. Okay, so I get 586. Divide that by 40. So 293 over 20. In case you're wondering, that's 14.65. Okay, subtract 3.7 squared equals 24 over 25. Okay, so it's the square root of 24 over 25. Alright, I must have typed that in wrong because suddenly my calculator said the old syntax error. So square root of 24 over 25. Okay, I get 2 root 6 over 5. And if it was a decimal, that is, let's just write in 0.979 something. Not rounding it, I'll just put the dot because I'm a fan of exact figures. Okay, so 2 root 6 over 5. Just in statistics terms, you'd like it like that. Just remember, of course, when you've got more than one data set, you want to compare the standard deviation with other sets of data, don't you? Okay, so comparing that with a standard deviation of 1 might be a little bit tricky because you might be thinking, well, what is 2 root 6? You know, divided by 5. So you can see it's just less than 1, isn't it? So when you write these as decimals, it is easier to compare. But that's it. Okay, that's all you do. Okay, hoping you find that useful. Okay, I'll see you again soon.